All right, 4-2, day 2. Okay, I want to talk right now about that other function we saw on the calculator, that binom CDF. Yesterday we used the binom PDF. That found the one probability for you, for the X number of successes only. Well, when we get to the parts B and C, it's going to be asking you for probabilities added together. And this binom CDF can be your shortcut. If you feed it the number of trials, the probability of a success on each trial, and then an X value. What this program does is it starts by substituting in 0 for the X, 1, 2, 3, and then stops at whatever X number you put in. So it adds up the probabilities, adds probabilities from X equals 0 to whatever X number you put in there, to the X value entered. So it will add P of 0 plus P of 1 plus all the way through whatever X number you put in. That's what the CDF, cumulative distribution, adds for you. So you don't have to do them all separately and add them together. So let's see how we can use this and when we should be using it. Going right into examples. Okay, they did a survey and found that 21% of men will choose fishing to be their favorite pastime. Okay, you are going to randomly select 5 men and ask them, what's their favorite pastime activity? And we're going to call a success the ones that choose fishing. So our first probability question, this is kind of a review from yesterday. Can you find the probability of exactly 3 people, 3 of the 5 men choosing fishing as their activity? Okay, and we've got 2 ways to do this yesterday. We did it by hand and we did it with the program. Today the only ones you're going to practice by hand are the ones that are exactly a certain thing. All the other ones we're going to use this new program for. So I don't know if I want to do this by program or by hand. What do you want to do?
Program.
Oh yeah, but you're going to have to do them by hand today though. So, okay, so which program are we going to use for this? The binom PDF or the binom CDF?
PDF.
The PDF. So you're going to use binom, I just use B, PDF, because the PDF one only gives you one probability. I'm going to show you what the CDF does in a minute.
It's going to be part of this question.
Yep, it's going to be a B and a C.
I'm going to say why you do that.
Yep, but we're going to have it all relate to the same information. So on the homework too, I don't think I said this yesterday, but I do want you to write down which program you're using by doing this, binom PDF. Tomorrow we're going to have 2 other different functions, Poisson and geometric. So this tells me binom PDF. Then tell me what you're putting in. In case if all you have is a wrong answer, you don't know why you got it wrong without having this written down. But once you have this, we can say, oh, you put the wrong X in, or you put the wrong probability in. So how many trials did we do on this one? 5 trials, the 5 men that were asked. What's the probability of success based on their study? 0.21. How many successes are we looking for? 3. So what is this probability?
How do we get the
Under distributions. Above the VARs, keep by the down arrow, right by the down arrow. And I do not have this answer written down. Let's go 3 places out. What do you get?
0.058.
So 058.
That's what I had to do.
Good.
I forgot how to do that.
Go to distributions by the down arrow, kind of, in yellow. And all the way down.
Oh.
Okay. What if I ask for the same information, what's the probability that fewer than 3 chose fishing as their favorite pastime? What does fewer than 3 mean to you?
1 and 2. 0, 1 and 2.
0, 1, and 2. Agree with that? So we are looking for the probability that 0 added to the probability that 1 added to the probability that 3 chose fishing. Or, no, do we want 3?
No.
2, that's what I wanted. I didn't go in order. I want those 3 probabilities added together. Well, we could use the binom PDF 3 times, get those 3 answers, and add them together. But there's a shortcut, and the shortcut is that CDF button. If we use binom CDF, tell it 5 trials, 0.21, what X value do I want it to stop figuring out the probability of? 2. Because remember I explained up here that the CDF will start with X equals 0 and stop at whatever X number I put in there. So by putting a 2 here, it will add 0 through 2 probabilities, 0, 1, and 2 probabilities together. It's all just built in. Just a shortcut. So go ahead and use the binom CDF. Tell me what you get. 0.934? Okay. Pretty good chance of that happening. Okay. Easy to use when you're starting the adding from 0. 0, 1, 2. What if I had said that you get at least 4 to choose fishing as their favorite activity?
Would be the same except for 2 and 4.
What does at least 4 mean to you? How many successes am I looking for? 4 and 5. I want it to add up the probability that 4 people say plus the probability that 5 people say.
Wait, where did you get the 5?
Because that's what at least 4 means in this situation. At least 4 means I want 4 or more, and I stopped at asking at 5 people, so it could only be 4 or 5.
Oh.
Okay? So I want those 2 probabilities added together. If we could do the binom PDF with 4, binom PDF with 5, and add them together separately, we can use the CDF to help us out here. What will if I had the table, what will all the probabilities add up to?
1.
100% or 1? So I want the 2 upper ones added together. Remember, this binom CDF starts adding at 0. Are you with me so far?
Yeah.
Okay. What chunk don't I want on the whole? If I had the whole table, which ones don't I want?
1, 2, 3.
0, 1, 2, and 3.
2 on.
So what we're going to do, so I want to keep 4 and 5. I don't want 0 through 3. I'm going to put them in a little to write that. But I know that all of these probabilities add up to 1. So the way we're going to use that CDF is to say 1 minus this bottom chunk that I don't want. Because I can get the calculator, that CDF, to add 0 through 3. The CDF always starts at 0.
Wait, what are we asking again? Like,
I'm looking, if I ask my 5 guys, I'm looking for the probability that at least 4 will pick fishing.
okay.
So 4 or 5. I want those 2 probabilities added together. So if I use the binom CDF, I'm subtracting off this lower chunk that I don't want. How can I get the calculator to add these probabilities together right here? I tell it 5, 0.21. What X value do you want to put in? It's the one you want added up and subtracted off, and that's this 3. This number here is what's going to go here. And you can type that all in one line on the calculator.
Why is it 3?
Because this is the part I want. I don't want 0, 1, 2, and 3 probabilities. I want it to add this chunk up.
It's 1 minus?
1. Because all of these probabilities will add up to 1. If I had the whole table there with 0, 1, 2, 3, 4, 5, and all the probabilities, they would all add up to 1. I want what's left over. I want these two. That will leave me with this sum. Does that make sense to you, or no? Do I need to make the table for you to see it?
It's good.
Well, yeah, it's good for a couple people that see it.
I don't get
Oh.
why it's a 3 there.
Because this is what I'm subtracting off. This will, by putting a 3 here, that will add P of 0 plus P of 1 plus P of 2 plus P of 3. It'll stop at the 3 because that's the 3 that I put there. It will add those 4 probabilities together. That give me this. And then I want 1 minus that. That'll leave me with the other 2. Maybe I should make the whole table so you can see it better. I think that might be a yes, or how many are not seeing it? I can help. I mean, well, I think the table would clear it up. What's going on?
I know what's going on.
Oh, Austin knows. Yeah, right.
What are you saying?
Right.
Did we get the final answer?
I don't know. No, I didn't.
.008. Okay, then I did it right. That's all I can close. I don't care.
Well, you have to be able to do it on your own. If you understand it, you'll be able to do it on your own. Let's try another one here. I'm going to change this to, it's .008. What's the probability that I get no more than 2 of those guys to say they like fishing? So tell me, what does no more than 2 mean to you?
0, 1.
Or 2. This means 0, 1, or 2. So I do want it to start adding from 0 and give me the answer to those 3 probabilities added together. What's going to give me that answer?
CDF.
The CDF one, 5 trials, 0.21,
2.
and
2.
Matt says 2. Is he correct? Yes, he is. It's the ones where it's the upper chunk where it doesn't start adding at 0 that are giving you, I think, some fits. And I'm going to do one more of those before we move on.
Wait,
Okay.
we already did one like that.
What?
Yeah, we already did one.
Oh, yeah, right.
I don't understand that one.
Well, do you understand the 0, 1, and 2?
Yeah.
Okay. Well, then the binom CDF starts adding from 0. And it'll stop at whatever x value I put there.
Oh, okay.
.934, do we agree?
Yeah.
Let me do one more that's an upper. At least, let's go.
Wait, can you do one of those other ones?
I am going to right now.
Okay, sorry.
I want another phrase that's above. At least
Greater than 2.
more than 2.
So, 3, 4, 5.
Well, let's go more than 3. No, we already did that. No. More than. Nope, more than 2. What does more than 2 mean?
3, 4, 5.
Well, that's the same one as at least 3. Let's go more than 3. There we go, that's different. More than 3.
Then what, were we just looking for 4 and 5 again?
We do that one too? We did exactly 3.
At least 4, we were looking for 4 and 5.
Oh, I'm looking at the wrong problem, that's why. Jeez, I'm like, why am I messing this all up? We did at least 4. Oh, more than 2. I was good. I was looking at the wrong one. More than 2. Go back to that. Sorry.
Start drinking.
Yeah. Start drinking. It'll make things better. It always does. Not. Okay, more than 2. What does more than 2 mean to you in this situation? How many successes am I looking for? I'm looking what does more than 2 mean? 3, 4, and 5. I want the 3, 4, and 5 probability added together. Okay, where does the CDF function start adding from? 0. I can't get it to start adding at 3 and stop at 5. It's impossible.
So you minus 1, or 1 minus.
So what chunk don't I want? The 0 through 2. This is the chunk I want to take off. But all of them add up to 1. So this is why we do the 1 minus, and I'll have it add up this lower chunk. How do I get it to add 0 through 2? Binom CDF 5.21, and what's our x value? 2. Very good. If you draw this little picture here, I want a picture, whatever you call this, little number line kind of thing, it's helpful. And what's this answer? 6, 6. Okay. Yeah, type that all in one line. So it actually does all the adding and the subtracting all at once. Try one more, new numbers, see how you do. Of these, before the last thing. Okay, 68% of Americans own a computer. Oh.
America. Yeah, this is old.
Oh, they had it at 27%, just so you know. I'm like, oh, I'm just going to throw a guess in here and say 68. The actual data for this problem was 27% of Americans have a computer in their home.
This book was made in 2000.
No, 1997.
No, it says 2000.
No, it doesn't. Do I need to break your fingers too? I don't want to do that twice in one day. You're going to select 6 different households. And ask if they own a computer. Can you tell me the probability that after you've asked 6 households, that exactly 1 household has a computer out of the 6 that you asked? We should do it by hand because you have to do some by hand today. So the exactly would go with, well, first of all, what would it go with? Which program?
PDF.
The PDF one, and you have to practice the by hand also. So, do you remember the formula from yesterday? Yeah, we'll just do this. And really, you could just write it out and then use the binom PDF, and I'll never know. If you just wrote out the problem as 6C1 multiplied by, what's my probability of success? 0.68 raised to the, nope, it was the x power, so in this case a 1, times the q, which is 0.32 raised to the, it was n minus x, 5th power. You could write that out.
And then just put it in our calculator.
And then you could type that in, or you could just go to the binom PDF. The answers are going to match exactly. I will never know if you typed this in or if you went and used binom PDF. Actually typing this in. That's fine. But I think a shortcut would be to go back and cheat and use binom PDF, put in NP and X. Just letting you know. There's a shortcut to this. This tells me you know the formula. Do I think you could type that in? Absolutely. So, but the binom PDF will give you the exact same answer, so I don't care which one you do. What do you get?
0.014.
Okay, it's been verified. All right, let's do our CDF. Let's go with no, more than 3 households have a computer out of the 6. What does no more than 3 mean to you?
0, 1, 2.
It's usually that last one. Do I include it or do I not? No more than 3. Do I keep the 3 or throw it away? Keep it. So I'm looking at 0, 1, 2, and 3. I want those 4 probabilities added together. Will binom CDF do this for me directly?
Yeah.
Because it's starting at the 0, it's just a regular old binom CDF with 6 trials, 0.68, and what's the X value that I want it to stop at? The 3. No, that's just cruel and unusual.
Yeah, I did it last
Any of the adding, yeah. The adding, we're always going to default to the CDF. The exact ones, we're going to practice a couple by hand. 294. And then our last one of these. At least more than, what other phrases are there? That's all I can think of for the upper.
That case is like greater than.
Greater than. Four. Greater than 4, or more than 4 of the houses have a computer. So what am I looking at getting? 5 and 6. I want 5 and 6. I can't get the CDF to start adding at 5. So this is one of those 1 minus business. What's the chunk I don't want? 0 through 4 is what I want to subtract off. I can get CDF to add 0 through 4. So I'll do a 1 minus binom CDF 6, comma, 0.68. What X value are you going to put in there? 4, because it's the part you're subtracting off. It's got to match this. 0.378. Okay, enough of that.
Is that all we're doing?
Nope, I got, those I see a lot of you didn't do it. The mean, variance, and standard deviation, the very last one with the table, how you had to run the 1-bar stat.
Yeah,
I've got a
I have
short-
no idea how to do that.
Oh, you just put your X's into a list?
Yep,
Put your probabilities into a list?
yep.
1-bar stats, L1, L2. You would have kicked them all out. Just like we did the day before.
And they did that. I don't know.
Okay. Because of this binomial distribution, we have some shortcut formulas. Shortcuts. But only if it's a binomial distribution.
Alright, Schwartz, I have to go read the little kids.
Okay. Do you want the assignment?
Oh, Matt Casey.
I'll get it
Okay.
after.
Shortcuts
It's like half a page.
for the, yep, well, less than half. Mean, variance,
You sure it's not one word?
I don't know,
I don't think so.
and standard deviation for a binomial distribution.
Schwartz is one word.
Okay, bring it together. Shortcuts for mean, variance, and standard deviation for a binomial, because you're going to have shortcuts for the other two tomorrow.
There's
So you won't-
cut and 1-bar stats?
Yeah,
No way.
you don't have to use lists at all.
That sounds like
The mean
Himself.
can be calculated just by taking the number of trials times the probability of a success. Done. That will give you the mean. Variance, which we know to be sigma squared, can be found by taking n times p times q. Done.
Oh, fuck that phone, that's I got that part right, because I had it on the
What part? This one not on your test?
card. It's like.
Like labeling the symbol?
Oh,
Yeah, same.
standard deviation. Obviously just the square root of that answer. Still. And then the shape of I did not make you graph. I skipped over the graphing. The shape of a binomial distribution can be determined by the probability of a success. If the probability of a success is greater than a half, means there's a good chance of it happening, we expect more successes. So if we were to make a histogram, your taller bars would be out here at the higher number of successes. So if it has a high success rate, the probability that you have just a couple of successes is very small. So the shape would look like this. Most of your successes would be out here on the high end. What do we call that shape? Skewed left. Remember, it's where the tail is at. Skewed left.
What is IC?
If the probability is greater than a half. If the probability is less than 0.5, we expect fewer successes because the success rate is smaller. So we expect the taller bars to be back here at the beginning of the axis. More successes here than out here. And we call that shape skewed right. And what's my last situation?
It's at.
If it is 0.5, what do you think we expect?
The bell shape.
That nice bell shape. Symmetrical. I have one more. Using all that. Just real quick.
How much space?
Not much.
You said half a page.
What was it?
Just last time. Like, when you started that new page, you said half a page.
Well, I thought she meant just the mean variance standard deviation. That was less than half a page. I was done with that before I went on to my next thing.
No, when we asked that, we mean like the rest.
Oh, the total? Oh, I thought you mean the thing I'm on.
Yeah.
Oh, sorry.
Yeah.
Okay. All right, in San Diego, %38 of the days are clear. That doesn't sound very good.
Says all that.
It's gotta be. That's awful. And that was in 1997. Find the mean, variance, and standard deviation for the number of clear days in the month of May. So on average, how many clear days are there going to be in the month of May? So this is a binomial situation. So we're going to use those shortcut formulas because I'm only asking for the mean, variance, and standard deviation. I'm not asking for any probabilities. I could ask for what's the probability there's 10 clear days, what's the probability there's 25 clear days, but we're not. So the shortcut formula for mean, N times P. N is the number of trials. How many trials am I doing? How many days am I looking at? 31 days in May. Probability of success, what's the probability of a clear day? 0.38. So the mean of the probability distribution. And the distribution would have went from 0 to 31. That would have been a horrible table to have to make and put into list 1 and list 2. That would have been obnoxious. Anybody?
11.78.
So about 12 days in May will be clear. Yeah, I don't think I'd want to live there. Variance, NPQ, 31, 0.38's the P. What's the Q? 6.2. Days squared.
Whatever that means.
Exactly.
Like, what does this measure?
How spread out the data values are. How many clear days there would be for, if we looked at all kinds of months of May. And then the square root of that,
2.7.
and then if, might as well give this shape. What shape would this distribution have? Let's see, it is below 0.5, the P, so it would be skewed right.
Wait, what has to be below?
The P. The P is 0.38, the probability of success. Okay, good. Now I'm done. Let's see, page 173. Problem number 1. 7 through 12, you're going to pick up parts B and C. Parts B and C. Number 14, skip B and F.
So 7 to 12, B and C only? Or
Yep,
no A?
we did them yesterday. 16 and 19 is the one I'd like you to practice by hand, just so you don't forget that formula. So 19 is going to be your by hand problem. Where you show me you know the formula. The rest can be done with the programs.